In this section, we're going to look at graphing these two rational or radical functions, the square root function and the cube root function. And this is going to be using the transformation rules, which is actually the same set of rules that we had used earlier with some other functions. So you need to, of course, copy these two functions down. And on each one of these, I have marked 3 points. And we're going to use these 3 points to do the transformations on my examples. Now, you have, of course, multiple points along each one of these graphs. I've just picked those 3 to use. So this is going to be your square root function. This will be your cube root function, okay? Now, here is the list of transformations. Again, it's the same set of rules that I had given you back earlier, but I have specifically written them based on what it would look like for a radical function. Now, I've used an n in each one of these situations, you know, as the index, because it could be a square root, but it also could be a cube root, okay? So if you have a number added or subtracted under the radical sign, that's going to be your left and your right shift. If the number that's added or subtracted is at the end after the radical, then that's going to be a shift up or down. If you have a negative in front's x-axis reflection, negative underneath is y-axis reflection. And then if you have a number multiplied times the radical, that's when you get a stretch or a shrink. If it's bigger than 1, if this number is bigger than 1, you call it a stretch. If it's between 0 and 1, you call it a shrink, okay? So you'll need to have these copied down in your notes to refer to as you work on your homework. Okay, the first one we're going to look at, and I'll scoot it over a little bit more for the graph in just a little bit. What you got to do first of all is just figure out what transformations. You've got the +4 and you've got the -5. So the fact that you have a number added underneath, then if you look back at your rules, that tells it it's going to shift left. So I want you to write down that you're going to go left 4. And then the -5. Okay, so see here, if I have a minus, then that means it's going to go down. So I'll have down 5. All right, this being the square root, then you're going to start out the 3 points that I gave you. That was 0, 0, 1, 1, and 4, 2. Now, I'm not going to connect them up. I'm just going to wait and connect everything up when I'm finished. All right, first of all, let's go to the left 4. So just take each point, shift each one over left 4. And then now down 5. So you just count each point down 5. So this would actually be your final graph. Now what I want you to make sure of with the square root function, it does not go in both directions forever. Like if I put this one back up here, see you've got an end point at one end, and then it does go indefinitely forever at this end. So make sure that you're not putting, you know, an arrow here and here. You do have an end point, okay? All right, next example. Okay, so I want to go through and list the transformations again. All right, underneath I have -5. So if you look back at your rules, having minus a number underneath tells me that we're going to go to the right that number of units. So that'd be right 5. And then having the negative in front, again, if you look back at the list of rules, having the negative in front is an x-axis reflection. Okay, so this is a square root again, so I'm going to start with the same 3 points that I started with just a few minutes ago. And then I'm going to perform each of these transformations. All right, so first of all, I need to go to the right 5. So now I need to take each of these points and do the x-axis reflection. Now, since this is your x-axis, you're flipping these points about this particular axis. So actually, this point that's on your x-axis is not going to move. This one, since it's 1 unit above, would flip 1 unit below. This one's 2 units above the x-axis, so it gets flipped to being 2 units below. Now remember, this is your end point, and then it'll keep going indefinitely this direction, okay? So that would be your graph for this one. All right, now let's look at a cube root. You're going to do the steps exactly the same way. We're just going to have different points to use. Okay, first of all, I've got the negative underneath, and actually having the negative underneath is going to be a y-axis reflection. Now, having the 3 multiplied in front, that's going to be the stretch. Remember, if you have a number in front multiplied, it's either a stretch or a shrink, but if it's bigger than 1, then it's referred to as a stretch. So we'll have a stretch by 3, okay? Now, the points I gave you for cube root, I gave you 1, 1, 0, 0, -1, -1, okay? So, first of all, I've got to do the y-axis reflection. Of course, this time, here's my y-axis. So the point here at the origin's not going to move, because it's right on your y-axis. But now your points flip this way. So this point will flip over here. This point will flip over here. So I've got these 3 points now. Now, taking those 3 and doing the stretch, okay? What I want to do, I'm going to write down the ordered pair for these 3. So this would be -1, +1. And then I've got 0, 0. And then this point would be +1, -1. Now, when you do a stretch, and I had this written on the notes, it says to multiply the y-coordinate times c. All right, so I've got to take my y-coordinate, which are these 3 numbers, and I've got to multiply each one of those times the 3. So this point would now be -1, 3. This one would still be 0, 0, because you do 0 times 3, you still get 0. And then this point would now be 1, -3. So my x-coordinate, my x's stay the same. I'm just multiplying the y-coordinate times 3. Now, if you'll plot these points, so -1, 3, of course 0, 0 is still, that point still hasn't moved, and then 1, -3, then these are the 3 points that I've got to connect up. Now, one thing when you're doing your cube root function, first of all, it's not a straight line down through these 3 points. So you kind of have to curve it, you know, a little bit in between these points. But the other thing is, this doesn't turn and go like down, and this part doesn't turn and go up real steep. After you go through these points, you know, then it pretty much kind of goes out, you know, left and right. This gradually goes uphill, this part gradually goes downhill, but it's very gradual, so you'll have more of a left and a right with it instead of it actually going up and going down, okay? Now, how you do the transformation rules is no different regardless of the function, okay? So the only thing that's going to be different is if it's a square root, you know, you've got these 3 points to use. If it's a cube root, you've got a different 3 points to use, okay?